Today, what I'm going to tell you about are polygons. And we've talked about lines and we've talked about angles, and now we're going to put them together and talk about polygons. And polygons, a polygon, it's a closed figure in a plane. Remember, a plane is a two-dimensional space. It's formed by three or more sides, and the sides only intersect at endpoints, and the intersections are called vertices. And we had talked about, hold on a second, we had talked about vertex with an angle. Remember, that's right there, that is a vertex. Well, if I have a polygon could be a triangle. This has three vertices. So vertice is the plural of vertex. And incidentally, polygon means many. Poly means many, and gon means angles. So it's something with many angles. Now, I've got some images down here in this sort of blurry picture of a variety of polygons. You've got your hexagon right there. You got a square, another square, equilateral triangle, a rhombus. But polygons also can look a little bit different than that, as long as it is an enclosed figure. Pretend that's enclosed. It's an enclosed figure, and all the sides meet only at endpoints, and also the sides can't be curved. So some examples of not polygons. So not polygons would be a semicircle, not a polygon. Let's see, this is not a polygon because it's not closed. And let's see, this is not a single polygon either because it intersects right there, right in the middle. So that is what a polygon is. And there are some types of polygons that we are going to talk about. The first is a convex, and that is when no line that contains a side contains a point inside the polygon. For example, here I've got a polygon, and if I look at all the lines, if I look at the lines that contain these sides, so there's a line, so let's see here. There's a line, you got to imagine that I'm actually on the line. There's a line, and there's a line. None of those lines contain a point inside the polygon. So that would be a convex polygon. Now a concave polygon, it caves in. Another way you can think of it, it's not convex. So if I had a polygon that looked like this, pretend that's a straight line. Well, whoops, this is a bad drawing. So let me just erase that and try again. Alright, let's try this again. If I had one that looked like this. This is a concave polygon because this point right here caves in. Also, if I drew the lines that contain this side and this side, see, both of those two lines go inside the polygon. So that's a concave polygon. An equilateral polygon, all sides are equal. So a rhombus is an equilateral polygon. So because all the sides are equal. An equiangular polygon, an example might be, I don't know, a rectangle because all of the angles are 90 degrees, but all the sides aren't. Well, a regular polygon is both equilateral and equiangular, meaning it could be an equilateral triangle, so all the sides are equal and all the angles are equal. It could be a square because all the angles are 90 degrees and all the sides are also equal. So there are two examples of regular polygons. Now here we have some better drawn regular polygons. We have a triangle, that's a three-sided one. A quadrilateral, also known as a square. A pentagon, a hexagon, a heptagon, an octagon, a nonagon, a decagon. Then we have like an 11gon, and then if we were talking about a 12-sided one, 12 sides is a dodecagon. Dodecagon. So that's 12 sides. Anything above 12 sides, as far as I'm concerned, you can talk about as just say the number of sides. So say, for example, a 13gon, or a 21gon, or an n-gon. And n is the number of sides. Okay, so let's take a look at some examples of what of some polygons. So first of all, this is an isosceles triangle. So it is convex. It's not regular, it's not equiangular or equilateral. This is a trapezoid. And a trapezoid, if I was to classify this, I would say it's convex. And then if I had this polygon, that is a concave polygon. How about this polygon? Well, it is convex, it's equiangular, and it's equilateral, so it is regular. All right. Let's see here if I can come up with a cool problem that you may be faced with. Okay, let's say I have a hexagon, and it's regular. Each side is 2x centimeters. The question is, what is the perimeter? Well, if a hexagon has 6 sides, so 6 sides, each side is 2x, so it would be 6 times 2x, or 12x. And so that's my expression, it's 12x. Now what if you had a problem that I gave you? I said, let's see here. The perimeter of a regular pentagon is 200 inches. Each side Let me see. Each side is 4x inches. And then I said solve for x. Well, first of all, a pentagon has 5 sides. Each side is 4x, and I know that each side is the same because it says it's regular. So 5 times 4x equals, and my perimeter is 200. 200, so 20x equals 200. Divide both sides by 20. X equals 10. So there is a brief rundown on polygons, and I will see you in class.